Bismillahirrahmanirrahim. Welcome back. In our last lecture, we had demonstrated various aspects of GPIO pins, and we were using the LEDs to uh, to see how we can set the various pins high and low. We are exploring basically the output part of GPIO pins. So similarly, when we how we can control these LEDs, we can arrange these LEDs into various different forms and get a different type of results. For example, in a 7-segment LED display, there are LEDs which are arranged in the form of a number 8, and just by controlling different LEDs turned on and off at different times and in different conditions, we can make different numbers. Like, for example, if we run this program, we can see that we can make various numbers uh, with this display. And if I also turn this on, these LEDs, you can see it is basically a combination of the various LEDs which is being turned on to make these numbers. So in this demonstration, we will be talking about these 7-segment displays, um, particularly single number display, just to have the main idea that how these displays are controlled. And later on, we will be talking about the displays in which multiple numbers or multiple digits can be displayed. But first, we have to know how to control a single digit display. So let's begin um, our presentation. So I hope you all know about me. I'm Amir Iqbal Qureshi. Professionally, I'm a heart surgeon and I enjoy electronics as my hobby. And as much I love teaching and sharing my knowledge with the other fellow students and hobbyists. Hallroad.org is one of the very popular electronics and component supplying um, organization or a sort of business here in Pakistan, and they are very kind enough to sponsor these videos, not financially, but in the form of providing various components and tools, etc., so that we can experiment. Right. So we are going to talk about the 7-segment LEDs and their display basics. We will be using the STM32 microcontrollers, but this discussion is general and which can be ported to any microcontroller which you are using. So here is a picture of various LEDs displays. This is a single digit display in which there are seven LEDs which are arranged in this form to make various numbers, and also one LED is placed as a decimal point or a dot. Then there are displays in which two displays are, are present in the same module, and then there are three displays and four displays. Then there are others as well in which these dots are replaced by two columns, just like in a clock circuit. So these LED displays, basically they consist of LEDs, 8 LEDs, and all they come in two configurations. One is the common anode and one is the common cathode. In a common anode configuration, like in this, all the anodes of these LEDs are connected together, and they are brought out as a common number, common pin. In this case, pin number 3 and 8 are usually these, and all other cathodes they appear as the single outputs. So just like uh, uh, our LED arrangement, in this the anodes are open and the cathodes are common. So you can always configure in whatever way you want, but when you want to buy a module, you have to specify whether you want a common anode or common cathode one. The segments of these LEDs are fairly standardized and they have been named as A, segment B, segment C, segment D, E, F, and G. They are always made, talked about in this order. You will never find that this segment is A and this segment is C and this segment is, although these are individual LEDs, and you will have to figure out from the pinouts of your module that which LED is about which. But if you find a data sheet of these modules, you will always find that these segments have been labeled as A, B, C, D, E, F, and G, and DP for decimal point. So in common anode display, all the anodes are common and they have to be connected to the positive supply rail, and all the cathodes are floating and they can be connected to your microcontrollers definitely through the current limiting resistor as we have talked earlier. And in common cathode display, all the cathodes of the LEDs are connected together within the module. You don't have to connect them together yourself. They are connected within the module, and a common pin is taken out as common cathode, and all the other pins are available as floating pins on which you can connect the microcontroller pins. So as we have talked earlier, that these LEDs, when they turn on, they have a very low resistance, and they can take a lot of current from your microcontroller that can damage the microcontroller pin. So in order to limit the current through these LEDs, you have to put a series resistor so that the current through the LED does not exceed the current that can pass through this. Usually in microcontrollers, we have 5 volts or 3.3 volts output, and we want to limit the current within 220, within 25 milliamperes. That is usually the limit of your microcontroller pins. So a 220 ohm to 330 ohm resistor is almost enough for the display. But if your LED display is bigger enough and has bigger LEDs and that consume more current and more requirements, then you cannot drive them directly from the microcontroller. Then you have to use either the driver ICs, which take 12 volts or more voltage, and they specify the constant current to these devices, or you can use the transistors, etc., to provide a higher current to the segments. However, you will control those devices like transistors or those driver ICs using your microcontroller. But you'll be using relatively standard sized modules which can be driven directly through the microcontroller pins. Driving an LED is possible using the ICs which are specially designed for as an LED driver ICs, like this CMOS IC CD4511. This is basically a BCD to 7 segment display driver in which there is an output for the 7 segment displays without decimal point. So these are the for segment A, segment B, segment C, segment D, E, F, and G. And the inputs of this IC are BCD code, like means that is a decimal code for the binary code for the number, like 0001 for number one and 0100 like number for the number one, etc. So you provide a binary coded decimal BCD code here, and this IC will configure the various segments to be turned on or off to display that number. Like in this circuit, they have shown that these pins have been connected to the seven segment display, and that these BCD numbers have been connected through switches, uh, so that when you press a switch, this pin will become one, and when you release this switch will get zero from this resistor. So by arranging these four numbers, you can make a number from 0 to 15. So the numbers higher than 9, they will be shown as hexadecimal numbers like A, B, C, D, E. It depends. I don't remember whether this supports this hexadecimal numbers or not, or whether it decodes the inputs only between 0 and 9. Then you can use the microcontrollers uh, to control these driver ICs and to display the numbers. So from microcontroller you supply the PCD codes to these ICs, and then these ICs they display the seven segment display. So this can use you can do the computation within the microcontroller or your Arduino or your STM32 board or any board, and then use these ICs, specified ICs like this 4511, or there are many others to decode the number and set the various LEDs on and off to make the display on. However, the beauty of microcontrollers is basically to reduce the hardware. So if we need more ICs for that, it's not a good design in the microcontroller world. So we can use the programming techniques to make these numbers, and we can get away with these specified ICs. Like here, you can see there is a microcontroller. It's an 89C51 microcontroller, but any microcontroller will work. And its output pins are connected to various A, B, C, D, E segments of your module, and the common pin is connected to the VCC or ground, depending upon whether it is a common anode or common cathode. So when it is a common anode, the segment which you want to turn on should be turned 0, so that 1 comes from here and the current sinks from here and the LED turns on. And the segments which you don't want to turn on, they should be uh, turned high so that they do not turn on. So in other words, or in other case, when this is common cathode, the segment which you want to turn on will be logic 1, and the one which you want to turn off will be logic 0. Right. So, since microcontrollers and microcontroller outputs like these, they can be set as high and low individually, or you can make them turn on and off. So, you should have this sort of table in your mind, so that if you want to make number 0, so uh, all these pins A, B, C, D, E, F should be 1, and G should be 0. So this should be A, B, C, D, E, F. This should be logic 1s, and this should be logic 0, so that it is no longer emitting the light, like in this 0. In 1, segment A and B should be turned on. So for number 1, you have to convert segment A should be 0, B should be 1, C should be 1, D should be 0, E should be 0, F should be 0, G should be 0, and decimal point is a separate issue. So um, So you have to make these numbers or these masks before using these displays in microcontrollers. So this is the same circuit which we are using here. Sorry, which we are using in our Proteus example. So here you can see we have uh, microcontroller and the 7 segment display, which is common cathode, and there are 220 ohm resistors, and they are connected to PA0 to PA6. So this is segment A, this is segment A, this is segment B, this is segment C, this is segment D. So segment A is connected to PA0, and segment B is connected to PA1, and segment C is connected to PA2, and so on. So then we have to make a mask. So again, just like I have shown you in the previous slide, that to make a number 0, we need 1, 1, 1, 1, 1, 1, 0. So this turns out to be a hexadecimal number 0x3f, or you can convert it to an equivalent decimal number if you want. But in programming, usually we prefer using the numbers in hexadecimal form. Similarly, for number 1, this will be turn out to be 0x06. For number 2, it will be 0x5p. This is hexadecimal numbers. So we make an array of an 8-bit numbers, which we will call mask, and then these numbers will be put into the elements of this array. So mask of 0 will be 0x3f, mask of 1 will be 0x06, mask of 2 will be 0x5p, and so on. So using this 7 segment display, you can make numbers from 0 to 9, and also you can make some special characters using the same segment display, and definitely you will have to make the mask for code for these numbers as well. You can make A, B, C, D, E, F, H, I, J, L, N, O, P, R, S, U, Y, and this is although looks like 2, but it can be considered as Z as well. Then there are other displays with more segments. This is 16 segment display in which there are 16 LEDs in one segment, and with this the numbering system is this A has been converted into A1 and A2, then again B, C, then D1 and D2, then E and F, then G1 and G2, then I, J, K, L, M, etc. So using the various combinations with these LEDs, you can make better letters like this: January, February, May, September, March, July, November, etc., etc. So the concept will be the same, but there are more LEDs packed in the same module. So let's go back to our presentation, and we will be making this program. So in our software, first of all, we have defined this mask array, and with those same numbers which we have discussed in the presentation. And now in our code, uh, let's try some numbers. Right. So first of all, right, let's write a single number, hall underscore GPIO, right, GPIOA, because our port A is being used. And here the pin mask, we will write mask of, let's say, 0, and pin state, let's set to GPIO underscore pin set. Let's only compile this and see what will be the result. Let's build the project. And we have already included this into the program file. And when we run it, you can see a number 0 is being shown. So if we change this to mask of, let's say, 7, so then 0, 1, 2, 3, 4, 5, 6, 7. So this number 0x07 will be set into the various pins and those pins will be turned high. So let's see project, build project, and when we run it, the number 7 is displayed. So now it becomes very easy. We just replace this number 7 with the required integer or the variable which you want to display, and that number will be displayed. Now let's see um, uh, this small code. I don't want to write it again. It's already here. I had written it before. Just uncomment it, control and this. So here I have used a variable x. Its value is being varied from 0 to 9. X is less than 10, and every time x will be incremented by 1. And before setting the next number, we have to clear the previous number so that all LEDs are turned off. So we write GPIO pin 0xFF means all pins. FF is 1 1 1 1 1 1. So this mask of uh, all the pins, 8-bit pins, and we reset them. And then we set the GPIO right, GPIO mask of X. So instead of writing mask 0, mask 1, mask 2, we use this number X to set the various pins. And then there is a delay of 1000 milliseconds so that we can see the result. And now let's build this project and see what happens. So now you can see it is showing us a counter. The number which you have got this number, and from anywhere, it can be a sensor value, it can be anything. So if you got a value in X, you can get to display it. So why we use this thing? Because if we do not show this, and let's see what will happen. The first number 0 is displayed and all other numbers are being displayed, but they cannot be shown because the LEDs are not turning off. So before showing the next number, we have to turn the LEDs off. So for that, you have to set all the pins. 0xFF is all 8 bits. So all 8-bit pins will be turned, reset, be turned off. And when you compile this program, just like before, we have seen that now the display will be showing the numbers correctly before setting the new LEDs. All LEDs are turned off. So I hope this presentation uh, you will have gained some knowledge about the 7-segment displays, how to control those displays, and how to make the masks. You can make masks for other displays like number A, B, C, and so on. And similarly, if you are using the 16-segment display, you can make even more uh, characters with those displays. So thank you very much and keep watching and do subscribe to our channel so that whenever we upload a new video and new demonstration, you always sit in the front row and get the notifications earlier. Thank you very much. Stay blessed. Allah Hafiz.